Okay. In order to understand how a rosette strain gauge works, let's see first of all what a strain is. Say for example, you have a length, you have a device, an element of length L, a rod of length L. Fine. On application of strain, pressure extra, it gets expanded to length L dash. So strain is simply uh, represented by epsilon. It is given by L dash minus L divided by L, the change in length divided by the original length of this the element. Fine. But at times we are not interested in the uh, average strain. The formula L dash minus L divided by L gives actually the strain on the complete length of this rod. But we are actually sometimes concerned with only on the strain at a particular point. So in such a case, what we can do is we are taking the same element of length L. We are assuming there is a point P at a distance of x from the 0 point. Fine. In this neighborhood of this P point, we'll take a uh, infinitely small length dx. Fine. So this is our original rod. On expansion, what happens is that P gets shifted to P dash. So uh, no longer the distance of P is x from 0. Now the new distance from 0 is x dash. Also, what happens is that the small portion of area length that we had assumed initially of length dx that will also expand and our new length will be dx dash. Fine. So in such case strain epsilon it will be given by dx dash minus dx upon the original length that is d of x. So on expansion the new strain will be dx dash minus dx divided by dx. We are only concerned with that infinitely small portion of length dx. Fine, we are actually only concerned with the strain in that portion. Now it's not possible for us to measure that distance dx dash. So what we can do is we can represent it in terms of the measurement of distance x and x dash. We know that uh, p gets displaced to p dash. Fine. So let this displacement be equal to s. So s is nothing but x dash minus x. So that means ds will be nothing but dx dash minus dx. So in other words, we can now say strain is ds divided by d of x. So the displacement of point P to P dash can be measured in terms of x and x dash. That displacement over the ordinal length of the displacement of that system can now give us the strain at that very particular point. Uh, Now, in order to understand how a rosette actually, we actually want the strain gauge to be able to measure strains in different directions, strains at different points. Fine. We do not want the average value of strain. So what we are saying is that we need to measure a strain at a particular point by measuring strain at that particular point originating from different directions, from different arbitrary directions. In order to understand that, we need to understand the 3D dimensional model of strain. So let's take a 3D any surface, a 3D surface. Say for example, on this 3D surface, we have a point P. On expansion, what happens? This point P gets shifted to P dash. Fine. So our rosette actually measures strains in different directions. In order to understand that, we first of all need to understand three-dimensional strain. We are assuming a 3D body. On this body, we are assuming, and it has on this body, we are assuming a point P. On deformity, this point P will get shifted to P dash. Now we need to understand the strain on this body. Now there is no fixed direction for us to measure the strain on this particular point. So we are interested in finding shear strain at point P. Let let us assume a three-dimensional coordinate axis x, y, z. Our point P is here. It gets shifted to P dash. Fine. So this displacement S here, uh, we know that when point P gets shifted to P dash, the strain can be measured in terms of ds divided by dx. But we do not here know the displacement x. Fine. This displacement through the help of coordinate geometry, we can say if these two vectors, say for example, this is r and this is r dash, and we can actually say s is r dash minus r by the vectorial by vector algebra. We can simply say s is nothing but r dash minus r. So the strain displacement relationship for this particular case can now be summarized by the vector algebra law, and accordingly we can derive strain as realize also this thing that I'm actually once I'm saying displacement s or dash minus r, I'm actually referring to only one plane of reference right now. Similarly, that is xz plane. Similarly, point P can be mapped to yz plane. Say for example, P is somewhere here, P dash is somewhere here. You can view it, you can visualize the three-dimensional graph. So there will be displacement of P to P dash. Say for example, this is S1. This can be termed as S2. Similarly, P can be mapped to XZ plane and it will be transformed to PP dash. So this displacement can be S2. Fine. So you have S1, S2, and S3, XZ plane, YZ plane, and X. Uh, the first one was XY plane. Sorry. ठीक है तो आपके पास एक थ्री डायमेंशनल बॉडी है एक कोई स्फेयर है आपके पास आपने उस पर एक पॉइंट पी कंसिडर किया you are deforming this body in whatever fashion you want so this p is getting deformed with respect to all three planes of reference x y y z and x z so there will be displacement with respect to all three fields of references x y y z and x z fine now you once we are actually trying to measure now shear, we are trying to measure strain at this point P, we have to take into consideration all these strain uh, that is ds1 by dx plus ds2 by dx plus ds3 by dx. Fine. So in this, now we can actually summarize them. We can say there are three different types of strains, ex, ey. So simply saying, I'll say there are three different uh, strains delta S1 by delta X, delta S2 by delta X, delta S3 without going into the coordinate geometry here. You realize now, after जो point P है, it's in a three-dimensional space. You are applying some strain with respect to all three fields of references. That's x, y, y, z, and x, z. आपका पॉइंट P मूव हो रहा है from P to P dash. So you need to measure displacement in all the three fields of references, and you need to understand that there will be three different strains with respect to three different fields of references: ds delta s1 by delta x, delta s2 by delta y, and delta s3 by delta z. Fine. Then you can actually derive. We do not want to go into that. Um, फिर आपको पता ही है with respect to vector algebra there is you have I, J and K, so you will have uh, shear strain E y z equal to 1 by 2 of delta W divided by delta Y plus delta V divided by delta Z. And similarly, E z x will be 1 by half of delta U by delta Z plus delta Y by delta W by delta X. So if you are, I am saying if we have U, V and W, the three displacements. So you have x, y, and z, the three coordinate reference frames. So हर किसी coordinate reference frame में अब strain का एक particular value होगा. But my point here was to only focus on this thing that once calculating the strain on a particular point, we cannot measure simply the strain in one direction. We need to measure the strain in three different directions, and now we are more equipped with the three-dimensional geometry, so we can accordingly choose a three-dimensional model for obtaining the strain at a particular point. Fine. Uh, Similarly, now if we are actually trying to, we have now two different types of strains. We can take the average of those two strains. That will be given by 1 by 2 of one strain plus another strain. Fine. If we have three different strains acting on a body, we can take the average of three different strains, 1 by 3 of A plus B plus C. Now, if we use a strain gauge, three different strain gauges uh, to measure strains in three different uh, coordinate axes in three different planes of references, it is going to be difficult with us with three different strain gauges, because the point is that will not actually be adapting to the changed strain, or will not be able to actually exactly measure the direction in which the strain is measured. So that's why we switch to rosettes for strain measurement. So what happens in case of a uh, strain? Uh, what happens in case of a strain rosette is we actually we actually take three different sets of coils, and they are coordinated or they are aligned in a particular fashion. Now, depending upon the alignment of these uh, wires or coils, we can form three different types of strain gauges. We can have the rectangular strain gauge, we can have the delta strain gauge, we can have a two-wire element based strain gauge. Uh, so all these different strains, say for example, we take a case of a डेल्टा स्ट्रेन रोजे. सो इसमें क्या होता है कि इसमें एक सेट ऑफ कॉइल्स जो होते हैं दैट्स एक्चुअली रिप्रेजेंट्स वन स्ट्रेन गॉज, they will be located they will be located at a particular angle. Another strain which will be aligned with respect to x, it will be located at one strain will be located in this direction. With respect to y, you'll have another strain gauge. Now this basically depends upon the applications. What we can do is we can actually use a delta strain gauge, we can use a rectangular strain gauge, we can use a two element strain gauge. तो इनमें difference क्या है कि इनमें जो ये different coils होते हैं, they are placed in a particular angle with respect to each other, in a particular manner with respect to each other, so that we can actually measure different types of strains acting on a body in different directions. Fine. So in a डेल्टा टाइप स्ट्रेन गॉज विल हैव दिस फॉर्म, एक कॉइल 30 डिग्रीज पे होगी, दूसरी कॉइल फिर उसके 60 डिग्रीज पे होगी, फिर तीसरी कॉइल उसके 60 डिग्रीज पे होगी। रेक्टेंगल स्ट्रेन गॉज में जो तीन स्ट्रेन गॉज होते हैं वो 45 डिग्रीज पे लोकेटेड होते हैं। सो ईच एलिमेंट विल बी able to measure a particular value of strain. Say, for example, this measures EA, this measures EB, this measures EC. Now we know actually the angles they are forming with respect to the coordinate axes X, Y, and Z. So accordingly, we can derive the values of EX, EY, and EZ with respect to the coordinate axes X, Y, and Z. Fine. So EX, say for example, in this case, uh, Ex in this case will be 2 by 3 of Ea minus 1 by 2 of Eb plus Ec. ठीक है, depending upon the angle, ये sin थीटा cos थीटा वगैरह वो सब कुछ इसमें कैलकुलेट करना है। तो अगर आपको इन डेप्थ देखना है तो आप थ्री डायमेंशनल स्ट्रेन कॉज देख सकते हो, हाउ a particular at a particular point in a three-dimensional space you are able to, with respect to the coordinate geometry, you are able to trace the value of strain at that particular point. ठीक है, तो आपको एंगल्स देखने हैं with respect to x axis, with respect to y axis, with respect to the z axis, वो क्या एंगल फॉर्म करते हैं अकॉर्डिंगली उस पर्टिकुलर पॉइंट पे वो जो वेक्टर होगा whether it will be have a cos relationship, whether it will have a sin relationship, वो सब कुछ आपको देखना है। फिर अकॉर्डिंगली आई जे के रेफरेंस फ्रेम में आपको इसको ट्रांसफॉर्म करना है एंड यू विल बी एबल टू फाइंड strain in a particular direction, Ex, Ey, and Ez. So once knowing Ex, Ey, and Z, we can now say that this particular point पे based upon the coordinate geometry, by the use of vector algebra, you can say what should be the value of z at this particular, what should be the value of strain at this particular point. Now, where these are all approximations, so it is a better approximation than using a single strain gauge to measure strain at a particular point. By measurement of by using three different strains gauge, we can exactly say what should be the value of strain at this particular point.